In many space sci-fi settings, nuclear weapons are still seen as extremely powerful, but they're also seen as obsolete and ineffective in space combat. The main reason is that a nuclear explosion behaves very differently in space than it does on a planet. A Star Destroyer in Star Wars, a Federation starship in Star Trek, an Imperial battleship in Warhammer 40,000, or a heavily armored warship from the Expanse can have thick hulls, strong internal structures, and systems designed to survive enormous amounts of punishment. These settings go even further by giving their ships deflector shields, energy shielding, or even void shields. Because of this, simply placing a nuclear explosion somewhere near a ship in space doesn't really guarantee that the ship will be destroyed. The weapon still has value, especially against planetary bombardment or against space stations or poorly protected targets, but it becomes less attractive when a warship can just absorb or deflect much of that energy. See, the biggest difference between a nuclear explosion on Earth and one in space is the lack of air. We are used to seeing nuclear explosions shown as enormous mushroom clouds, but that shape depends heavily on Earth's atmosphere and gravity. On Earth, the explosion heats the surrounding air to an enormous temperature, causing it to expand violently and push against the air around it. This creates a powerful shock wave that can smash buildings and throw objects through the air. In space, there is almost nothing around the explosion to push against. There is no atmosphere to carry that huge wave outwards, so a nearby spacecraft would not be hit by the familiar wall of air we normally think of as a nuclear blast. The explosion would still release an enormous amount of energy, but much of that energy would be traveling through the vacuum of space as radiation and as particles instead of as a gigantic, expanding shock wave. The explosion also gets over in a blink of an eye, and so the thermal shock and the EMP that gets generated only lasts as long as the split-second explosion itself. Because there is no atmosphere to carry a normal blast wave, radiation, however, becomes one of the biggest dangers. A nuclear explosion releases a huge amount of energy as different forms of radiation and as extremely fast-moving particles. This includes X-rays, gamma rays, neutrons, charged particles, and intense heat radiation. This means the spacecraft doesn't have to be physically struck by a blast to be damaged. If it is exposed to the explosion from a close enough distance, the radiation can damage electronics, sensors, solar panels, and other exposed equipment. The explosion would also create an extremely hot cloud of ionized material called plasma. On Earth, the atmosphere strongly affects how an explosion develops, helping to create the familiar shape of a mushroom cloud. In space, however, there is no thick atmosphere to produce that effect. Instead, the hot material expands rapidly outwards into the surrounding vacuum, and the energy gets dissipated almost instantly as well. And not to mention that an explosion caused by a few kilograms of uranium or hydrogen, if it's a fusion bomb, will also cause a plasma cloud that is of the same mass, and that cloud is spread over quite a huge area, thus lessening any impact it would cause, since that mass is spread as a sphere in all directions. But then again, the lack of an atmosphere doesn't really mean that a nearby spacecraft would simply be pushed aside unharmed with a single radiation wave. The intense radiation from the explosion can still rapidly heat the spacecraft's outer surface, especially if they are directly exposed. If the heating becomes strong enough, some of the surface material can vaporize and shoot away from the spacecraft. That escaping material can act almost like a tiny rocket firing from the surface, giving the spacecraft a sudden push. At the same time, the intense radiation can damage or destroy exposed parts, so there can still be serious physical damage. But the process is very different from what happens during a nuclear explosion on Earth. Instead of a giant wall of air smashing onto the spacecraft, much of the damage comes from intense heat radiation heating the spacecraft itself. Then there is another important difference which involves electromagnetic effects. On Earth, one of the ways a nuclear explosion can create an EMP or an electromagnetic pulse works by releasing a massive wave of gamma radiation that strips electrons from air molecules via the Compton effect. When these free electrons interact with the Earth's magnetic field, they produce a powerful, fast-moving electrical and magnetic surge that induces destructive voltage spikes in electronic systems. Space doesn't really provide that same environment because there is essentially no atmosphere surrounding the explosion. This means you would not simply get the same kind of large-scale EMP. However, that doesn't mean electronics are safe. The explosion still produces enormous amounts of radiation and fast-moving charged particles, which can interfere or damage spacecraft electronics and electrical systems. But it's actually negligible in comparison to the EMP wave that is produced in the upper atmosphere. This is where science fiction often gives us a confusing idea about how nuclear weapons work in space. A nuclear weapon would not necessarily have to physically hit a spacecraft to cause serious damage. At the same time, the danger decreases with the distance because the explosion's energy spreads over a much larger area as it travels outwards. This means that a nuclear explosion in space is not really a bomb creating an enormous shockwave. It is rather like a flashbang, but with just a split-second heat wave. It is better understood as a sudden burst of radiation, energetic particles, and expanding hot material moving through the vacuum of space. That difference is extremely important for science fiction because it means that nuclear weapons, like how they split the asteroid in half in Armageddon, wouldn't necessarily work like that. And then there are some sci-fi creators that realized that and therefore relegated the nukes as weapons of a bygone era. And so this is where the more advanced weapons like beam weapons, plasma cannons, and railguns become much more useful. Instead of releasing a huge amount of energy in every direction, these weapons can concentrate their destructive power into a much smaller area. A Star Trek phaser or a Star Wars turbo laser can direct energy towards a specific part of an enemy ship, while Warhammer 40k uses weapons like lances that focus tremendous amounts of energy onto a target or just super massive explosive shells which are fired from macro cannons. The Expanse takes a more physically grounded approach with railguns, missiles, and powerful conventional weapons that can deliver their energy directly onto the ship. This matters because a warship is not simply one giant piece of armor. It contains engines, weapons, sensors, power systems, and crew areas. So concentrating damage on important sections can be much more effective than a nuclear explosion, which is just a split second and just releases heat energy. Even if a nuclear weapon produces far more total energy, a directed weapon can put more of that energy exactly where the attacker wants it. Another major reason why nukes are obsolete is that future warships are often designed around surviving the kinds of attacks that would make nuclear weapons useful. In Star Trek, deflector shields can absorb or reduce incoming energy before it reaches the hull of the ship. Star Wars ships commonly use powerful shielding combined with armored hulls, while Warhammer 40k warships can have enormous layers of armor, internal structures, and void shields designed to protect them from weapons that are already vastly beyond modern human technology. The ships of the Expanse are less fantastical, but they are still built with heavy armor, with strong structures and systems that allow them to survive extreme combat conditions. In these settings, the warship has effectively become its own defensive system. A nuclear weapon might damage it a little, but an advanced beam, a plasma weapon, or a railgun can repeatedly attack the same target and keep putting destructive energy into specific point areas. This makes such weapons much more practical for sustained ship-to-ship combat, where accuracy, a rate of fire, and an ability to attack specific systems matter just as much as total explosive power. Nukes therefore tend to remain important in other different areas. They are excellent weapons when a target is large, exposed, or difficult to protect, and a large nuclear strike can devastate infrastructure across a huge area. This is why many science fiction settings still use nuclear weapons for planetary bombardment, for strategic attacks, and situations where overwhelming area damage is much more important. Against sci-fi warships though, the situation is different. The ship may have shielding, heavy armor, enormous size, redundant systems, and advanced damage control, while the nuclear explosion itself has no atmosphere to turn its energy into the devastating pressure wave that we associate with nuclear weapons on Earth. This doesn't really mean nuclear weapons would literally be useless in space combat. A sufficiently powerful nuclear weapon could still be dangerous, particularly at close range or against an unshielded target. Rather, in these fictional settings, nuclear weapons have been overtaken by others that can deliver enormous amounts of energy more precisely and repeatedly. That is why a Star Destroyer fires turbo lasers. A Federation starship uses phasers. An Imperial battleship of 40k relies on lancers and macro cannons or even vortex weapons, and an Expanse warship uses railguns and missiles. The nuclear bomb remains a powerful strategic weapon in planetary battles and in orbital bombardments, but the everyday weapons of a futuristic space navy are designed more specifically to fight other futuristic warships. This is the main reason why humanity in Halo cannot overload Covenant shielding with nuclear weapons, why the Tauri in Stargate can't even penetrate the Goa'uld Huttaks with gigaton level nukes, and why Star Trek have shifted into matter-antimatter warheads, or that 40k simply uses vortex weapons, which are super fictional to say the least, but are very destructive. However, a nuclear weapon detonating inside a starship would be a completely different matter from one exploding outside the hull. Inside a sealed spaceship, the surrounding air, machinery, walls, and internal compartments would give the explosion material to push against. The enormous heat would rapidly turn the nearby air and materials into extremely hot expanding gas and plasma, creating a powerful pressure wave that would race throughout the ship's interior. Since the hull is being attacked from the inside, the ship's armor and external shielding are in a poor position to protect it, especially if they are designed to stop threats coming from the outside. The pressure, the heat, the radiation and expanding material, along with the ship's own hull, trapping much of the expanding energy for a short time, instead of allowing it to freely escape into space, would cause a sudden explosion and would result in a fireball that would seem to last longer. This is why science fiction often treats the delivery of nuclear weapons inside an enemy vessel as a far more effective tactic. In Stargate, for example, the Tauri SG-1 used a similar tactic to destroy Ra's mothership and later to destroy the Wraith Hive ships and the Super Hive. This was also seen in Halo when the Master Chief delivered a nuke inside one of the Covenant ships. That same style was also seen in the movie Independence Day, and there are tons of other examples out there, which you can comment down there in the comment section below. And so there you see, this is why nukes or nuclear weapons are seen as almost obsolete in regular ship-to-ship combat. They have the explosive power, but their explosion in space doesn't create a similar effect as the one seen on Earth or inside a planet's atmosphere. The explosion is just a flashbang of heat energy that is almost instantly dissipated, and therefore the use of beam weapons, plasma cannons, railguns or even vortex weapons are seen as more useful or more logical in space combat in sci-fi. And so with that we end this video. Do hit that like button for support and also click that bell button for regular updates on new video uploads. Also subscribe to be a part of Legion Nutbuck, and till the next time, take care boys.